Welcome to my video on completing the square part 2. In this video, we are still going to be taking our quadratic expressions ax squared plus bx plus c and turning them into a squared binomial, something of the effect of d times x plus or minus e squared. But this time, we're going to have a value for a that is not 1. It's going to be a number bigger than 1. It could be anything. It could be positive, it could be negative. And in order to complete the square, we need it to be 1. So we are going to see how do we handle it. And then it's still going to be the same approach after we take care of a. So let's take a look at some examples and see what we can do. Alright, in this example we have 2x squared plus 12x plus something. And we are trying to complete the square here. So what we are going to have to do is we are going to have to get rid of the 2 in front. We are going to factor it out of these two pieces. So let's start by factoring that out. We have a 2 that we're dividing out, and that gives us x squared plus 6x, and then plus that. Okay, we factored it out of everything. And since we don't know what this is, the 2 is going to affect it in the end anyway. So we have now factored away the 2, and inside a is now 1. And this looks a lot like what we did in part 1. So, what can we do? We can take the b term, which is 6. We can take that 6 and cut it in half, divide it by 2. And then we can square it. 6 divided by 2 is 3. 3 squared is 9. And now we have completed the square for this, x squared plus 6x plus 9. Now that we have that 9 there, we could say, oh, the original number needs to be 18. And why is it 18? Well, because we factored a 2 out of everything. But what we actually want to do is we want to leave it like this. We're going to leave it like this because we can factor it further. And if I'm distributing the 2 back into everything, that's not going to be factoring. That's making it less factored. So we're going to not worry about that. We have this down here. And what's inside the parentheses we know is a perfect square trinomial. So we can use that little shortcut and turn it into x plus 3 squared. But don't forget the 2 on the outside because that was part of the original. So we have 2 times parentheses x plus 3 squared. And now we have used the completing the square technique and factored it down to a perfect square binomial. If you're confused about how I did that to get the x plus 3 squared, I highly recommend you go and watch my video on factoring perfect square trinomials part 1 and part 2. Alright, now that that is done, let's try another example. It's going to look very similar to this. We're going to need to factor something out, find that third term, and then turn it into a perfect squared binomial. Alright, here's our next example. We have 4x squared minus 48x plus something, and we want to make this a perfect square trinomial so we can factor it. So, a is 4. We want to get rid of that, so we will factor a 4 out of everything. That's going to give us x squared minus 12x plus something. We still are looking for that something. And since we have the x squared term where a is 1, we can do the completing the square technique on b. We're going to take that b, which is negative 12, We're going to divide it by 2, and we're going to square it. So that is negative 6 squared, which is 36. And that's what's going to go here, 36. So we now have our perfect square trinomial. We factored out whatever a was. We took b, cut it in half, and then squared it. Make sure you divide it first before squaring. If you square then divide, you're going to get a different number. And then whatever that was, that became our constant at the end. And now we can factor this into a squared binomial. So it'll look something like this. Don't forget the 4 has to go in the front because we had the 4 multiplying by it there. And what goes in the parentheses? Well, x squared is x times x, so that's x. 36 is 6 times 6, so that's 6. And then b was negative, so it'll be x minus 6. And there we go. We have completely finished this problem. And really, that's all there is to this method. Get rid of a by factoring it out, and then use the completing the square technique from part 1. We'll do one more example where it doesn't work out as nicely, so we'll see some uglier numbers, but it'll all be usable and done in the end. So let's take a look at one more example. All right, here we have 3x squared plus 7x plus something. A, once again, is not 1, so I have to get rid of a. I got to make it a 1, so I'm going to divide away the 3 from everything. The 3 is going to go on the outside. That's going to leave me with x squared, but 7 isn't divisible by 3. So we're going to leave it as 7 divided by 3x. Not the nicest of numbers to work with, but I'm doing this to show that this method will work with anything. And then we're still looking for that term in the end. Well, now that I've factored out the 3 and my a is 1, I can take b, which is 7/3. Oops. So I'm going to take 7/3, that's a 2. I'm going to divide it by 2, making it a compound fraction, and I'm going to square it. So, let's think about this. 7 divided by 3 divided by 2. What this is going to be is really 7 divided by 6 to the second power. Because when we divide by 2, quick little fraction lesson here, if I have 7/3 divided by 2, this is the same thing as 7/3 times 1/2. You multiply by the reciprocal. 7 times 1 is 7, 3 times 2 is 6. So, this turns into 7/6 squared, which is 7/6 times 7/6. And we get 49/36. And there is the term that makes this a perfect square trinomial. And then we can factor it one last time. So this is going to equal 3 times x squared. Sorry, not x squared, 3 times x plus 7/6 squared. Remember, we get this by taking one of those. And we're done. We have successfully factored this all the way. Hopefully you found this useful and easy to understand. Good luck with completing the square.